Hello all, welcome to my channel. I'm back with another video on data platform slash engineering topics. In this video, we will discuss about the newer options or newer alternatives which are available in open source or partially managed way that are substitute to Kafka, which is Apache Kafka basically. Um, so let's get started and see what we have in this video. So it's all if we look at the timelines, so this is how the timelines are for different solutions which are there. So Kafka was started at LinkedIn and then it got the folks who created this created a new company called Confluent and they started to offer managed services for Kafka. Then we saw a wave of new solutions which are coming up like Red Panda created a company Red Panda created a event store, something similar to Kafka. Then there was a company called Bufstream, which created a, stateless version of Kafka, storage optimized, so that we can reduce the cost. That later on got acquired by Confluent itself. Then we have Bufstream, which is a Protobuf first Kafka compatible solution, which directly uses S3. We have AutoMQ, which is again a solution built on top of Kafka's core code, and then removing the storage part. There are other companies as well. For example, there is a product called Stream Native Ursa, URSA. So that also is there, which is in the same space as others. So in this blog, we will see what challenges Kafka were having, and then why different solutions build different teams. So so to see some of the challenges that was there with Kafka was the scalability of it. Uh, in a sense, to maintain a consistent throughput and what you call performance at Kafka, we need a lot of parameters to be tuned. First is that the first challenge that was faced by Kafka, the consumers of Kafka, was the scale required. For example, if I am having, let's say, if I am trying to ingest 100 GB of data on an hourly basis, first of all, it has to be replicated across three nodes, and if we are on cloud, so we will have different AGs on which this data needs to be copied, which adds cost. So AG transfer data cost gets added. Then also Kafka has this limitation that the data is tied to the compute. So the storage is tied to the compute. So uh, each of the brokers stores certain part of the data, the topic data. For example, if we are using uh, each of the brokers will be leader for a certain partition, and then partition will only that broker will only serve the request for that particular partition of the data. So there are certain things which are tightly coupled. So if we have to scale, let's say we are trying to do certain processing, if we are having a network bandwidth issue, then again we will have to scale the cluster. Let's say if we add one more node or we add one more broker, so the whole redistribution stuff also comes into picture. So there, that was another challenge, that how to scale the storage as well as the throughput capacities independently. So that was not happening. Plus the cost associated of storing the data. As I mentioned in the example, that 100 GB of data needs to be replicated three times, so 300 GB of data, although we are only consuming one. And that because we are using disk-based volumes, SSDs are expensive and we can't leverage, uh, we have to pay a premium for that particular storage. Then the thought came to the folks who were facing these challenges is, why not make Kafka uh, decouple the storage, or at least offload the storage to, let's say, an S3 or an object storage which is present or available in let's say in on-prem or either on the cloud environment. So Confluent and open source community did have an option. They started with this strategy called tiered storage. So what it basically did is it exposed certain configurations in Kafka itself, which says local dot retention millisecond or local dot retention bytes. So this, what it used to do is it would offload uh, after the retention period, the data which was supposed to be present on the broker will get offloaded to an object storage. So instead of keeping it in disk, it will be offloaded to a remote storage. Let's say in case of AWS, it will go to S3. So this was one option which was added, but this there was a challenge. This not challenge, that there was a catch, that this offloading only happens for a cold data, not for an hot data. So what do we mean? That the active segments, so segments which are open for write as of now in the brokers, will not be sent to a object storage. They will remain in the memory. Only the segments which are not no longer active are moved to object storage. But this still was a great this still was an improvement. So this was just an cost. From the cost point of view, we could simply offload certain data which we did not need in the real time to an off object storage. So that was there, and there was no code change. There was nothing needed. Just a flag that we have to enable, and that would have worked for us. So the long-term scaling of the storage was the challenge that it was trying to solve, because object storage can scale independently and it can keep data for a longer time, and we can do a snapshotting. Means we can do a cleanup or archival as we need. So that also was helpful. And because we were not processing, not keeping the hot data in the active SSD of the brokers, that reduced the cost, because the uh, SSDs were only storing the active files rather than the colder or not so frequently accessed data. So this decoupling did a trick, and it did uh, reduce the cost significantly for certain large clusters. There was a new proposal, KIP, initiated, which is called diskless topics. So this basically means that when this is accepted, what will happen, that we can create a topic which will be completely diskless. So that will not be using the uh, local disk at all. It will completely sit on S3. And that, if once it is accepted, I'm not sure whether it has been accepted. It has been accepted. I think it was from Avian, but it is not yet fully available or fully battle tested in production environment of a new customer of the open source code base. There are customers who are using it, which Avian manages, but uh, in the open source community, there has been no documented production use at a large scale for this diskless topic. But that work is going on. Uh, After this diskless, what you call the tiered storage, there was another attempt by the folks of from Bufstream. uh, they implemented the Kafka protocol, but they said, okay, they actually redesigned the whole Kafka setup architecture, I will say, and they introduced the concept of Warpstream agent, which were stateless, and they used to do producing and consuming the data. I mean, the producer and consumer will consume data from agents. This is not an AI agent or something. It is just an agent, which it's a new name for the brokers basically. And the brokers didn't hold any data in their own premise, means own memory. They offloaded everything to S3. From the data point of view, certain indexing and certain routing decisions were kept in memory, but that again was persisted in metadata store. So how it looks is that we will have, so the upstream will create a metadata store, which will store the information of which partition is, which agent is responsible for which partition's data resides in which file locations, and stuff like that will be stored in metadata. So producer connect to the set of pools of agents, so they can connect, they will just simply say, I want to connect, and agent will this pool of agents, one of them will be assigned, and then it will stream the data for some time in memory and then flush it to the disk. And when the consumer comes up, it will again connect to any of the consumers. It will see, talk to the metadata store, see the offset and everything, and then start streaming the data from S3 object storage itself. So this was the design that they followed for the Bufstream clusters that was created. But there was one, means this is not a, when they launched, it was a commercial project. It was not open source, so you needed a license. And later on, it got acquired as well by Confluent. And then Confluent, I will not say at the same time, but it parallelly they launched, Confluent launched a cluster type called Confluent Freight Clusters, which was again, which was following the same strategy, that instead of using disk for the memory, disk for the data of Kafka, they were using S3 or object storage. Plus, they also removed the dependency on replicating data across edges. The reason that is not needed anyhow, if we are using object storage, because object storage, for example, in case of S3, is automatically replicated into 6 different zones. So there is no point, or there is no further incentive of doing that AG replication. The AG replication was useful for cases where we were using disk and disk were not replicated across AGs, so we needed data to be replicated, and that's where this data AG transfer cost was coming up. So hence Confluent decided to go let go that, and then they were able to build that platform. But now Confluent has both Confluent Flat clusters as well as Warpstream, and they will, I think, completely absorb this tech into either in their Freight clusters or in one of their own offering. As of now, Warpstream is available as BOIC in Confluent Cloud. And the numbers are that P99 write latency is 620, into in P99 read latency was, into in, like from producer to consumer was 1.27 seconds, and this was written in Go. So this was from the product success point of view, it was a success. It was acquired also by Confluent, considering its potential, and they were kind of, the Confluent team was kind of skeptical about how long they can offer, or they can put a competing offering in this case, and hence they decided to buy the company itself. So yeah, this was one offering which is there. Then there was another company called AutoMQ. This is again a fork of Apache Kafka. I will not say fork, but it has the code base, core code base common as Apache Kafka. And what they are trying to do is something what we have already seen. So they aim to make the brokers as efficient as possible. They are also offloading the data to an object storage. So their architecture is slightly different. They have chosen a hybrid approach. What they do is, so in this case, what their brokers do is they have two concepts. So you do a write, when we do a write, so the storage, so the initial write goes to an EBS. So they have a wall which is in cache, and and that can be backed by an EBS. So when we write data to the Kafka brokers, or sorry, AutoMQ brokers, it will first be written to an wall write ahead log, which is backed by an EBS volume attached to that particular broker. They don't do cross-zone data copy. So they don't have the cross-AG data transfer cost associated. And once they have written this data to an EBS, what they do is they asynchronously will upload that particular compacted wall to an object storage. In let's say if you are in AWS, it will be to AWS S3. So what will happen? The hybrid approach allows them to make the writes faster, and because if the offloading happens after some time, and but the memory in memory cache page caches, like the same sorry, the wall cache and everything, or tailing read will still happen from the memory, but for the longer reads it will take both routes and see. So see, the structure is like this. This is a Kafka producer, this is Kafka consumer, so and this is the AutoMQ's abstraction in this case. So we have object storage in here. What happens is the Kafka producer writes. So it writes to the in-memory buffer, then gets directly written to the wall storage backed by attached disk, or can be a remote file storage. Also, there is some configuration that we can choose, but generally it is recommended for latency sensitive applications to have it on EBS backed or disk backed. So it gets written to the wall storage, and then the acknowledge and send back that yes, I have received your data, your whatever you were trying to produce has been successfully written. Let's say the consumer call. So what it will first see, it will see whether the data that I am looking for is present in the message cache or not. If not, then it will do a tailing read of the wall storage, and it will also do a catch up read from the object storage if it is not present in here, and then combine the results and send the response to Kafka consumer. So this is how it works. So in certain cases, the latency will be high if uh, the live count, the live or the wall storage for that particular topic's data is already persisted to object storage, then it will be slightly slower. Otherwise, if it is recently being written, it will still be present in wall storage, and tailing read will do give a lower latency numbers while reading as well. So this strategy is being followed by AutoMQ. So again, and they have native integration with iceberg table topics, so where we can create a topic which is directly getting written to the lakehouse storage as an iceberg topic, iceberg table, and that you can query it as well from other engines if you need. So that's one added advantage of this. AutoMQ also has announced that they are changing the license. Previously, it was a company which was offering it fully as a managed service. Now it has made it to Apache 2.0 license, and it will be available for solution implemented. I mean, they also raised a, a request in the open source community to have their S3 stream capability, but I'm not sure whether that is going to be accepted as soon, because Avian's diskless topic is already present. So based on that, whatever happens, but this company still offers these solutions, and it is open source. We can try it out ourselves as well. Now we have another project which is called Bufstream. So Bufstream, so this company is unique in a sense. It was a company which actually created the protobuf. Uh, Once the people who created protobuf at Google then started this company called Buff, and then they also ventured into this streaming use cases by creating a product called Bufstream. Upstream is a Kafka compatible message queue built for Lakehouse era. Again, it does not uses any local disk attached to that. So their brokers are totally stateless. Brokers are leaderless as well as stateless. They don't maintain any state. So they also have a concept of metadata storage that they use separately. I think it is HCD, or it can be spanner as well, and they use object storage. And what happens is that whenever a client is trying to write, it can write to any of these any of the no brokers. So because it doesn't have, there is no concept of a leader for a partition. So that any client can write to any broker. That is the stateless nature, and it can automatically scale up and scale down as well. So we don't have to rely on like independently. It can scale up, scale down. So if we have throughput requirements, we can simply add one more broker, and the object storage will keep on serving the requests as it is. There are a few other things. For example, one is that if two brokers write to the same partition, ordering of event is revolved through the optimistic. So they have certain techniques to find out which brokers would be accepting the right request. They use consistent hashing, I think, to find out right broker for an topics partition rather than choosing a leader. And so Bufstream does not rely on disk. Data is stored in object storage in two layers. One is the received data is buffered in memory and then flushed to S3 as an intake file periodically, which is every 100 milliseconds, and where multiple partitions are written together. The intake files are archived by a background process. Default is 1 hour or 4 GB, whichever comes first, into the target format. Let's say if you have iceberg decided as the table topic format, so that will be converted into the table iceberg format. Uh, So this was here also there is no disk architecture, so we can scale up and scale down the brokers independently. It is fully Kafka compatible, so we can simply do a replacement of Kafka using this. That is again, and also it has two different I will say two unique things that is present in this solution is that Bufstream treats the schema as a first class object in Kafka, and the brokers can do a schema validation themselves. We don't means Buff has an schema registry called BSR that can be used with Kafka topics, which is present in Bufstream, and the validation will happen at the time and from the broker side itself. We can just simply define the schema, and the validation will keep what happening. We don't have to implement the logic. So that is another part. Plus, it uses the optimized protobuf format for message exchanges. So that is again something which uh, can contribute towards a higher throughput or performance value. Uh, Buff documentation claims that it is 25% cheaper than concurrent cloud and 1.5 times cheaper than Warpstream. But again, these numbers are something which is each vendor has their own numbers. I don't generally prefer this, but the numbers whichever is mentioned, the general idea is that because we are using object storage, so we will have certain latency numbers which will not match as the open source Apache Kafka latency numbers, but we will have to do a trade-off between cost. So cost will definitely be lesser compared to what we will see in the open source Kafka. So if our use cases are such that we can means we can tolerate certain latency or certain late data, we should actually explore these solutions because these have a lot of cost benefit attached to that. So this is uh, again, this is also one thing that all these ideas do not remove Kafka. So what they are doing is they are taking the ideas from Kafka and building a better solution. So Kafka will be there because the latency numbers, whatever requirement is there, will still continue to dominate the event streaming field. Uh, let's talk about another solution which is called Stream Natives Ursa. This again is a fully Kafka compatible solution which runs on top of Pulsar. I mean, it's not on top of Pulsar, but they have a lot of inspiration from Pulsar. So because they use the bookkeeper concept, which is a unique thing for Pulsar itself. So what it happens is what they have done is they have made the brokers zone aware and the brokers are stateless. There is no leader concept in here as well. So what happens? The consumer or the producer only talk to the brokers which are there in that particular zone. So there is no cross zone data transfer or movement that is happening. They also use consistent hashing to find out which brokers would go to which producer, or which producers would go to which broker, and how they manage the data. They have tunable latency numbers, latency configurations. Like for example, if you have low latency in applications, then you can choose for streaming storage. So they have three layers. One is their state broker layer, then they have storage layer, and then the metadata service layer. So in the storage layer, they have option of choosing uh, two types of wall. One is the latency optimized wall, which is backed by the bookkeeper, which will give you the latency number similar to what the open source Kafka gives. And then there is one which is called cost optimized wall, which uses object storage. So this will have lower latency numbers, but it will reduce the cost of your Kafka cluster very significantly. And then they have again all the topics you can configure to be written into as an iceberg table or a delta table. Delta is in preview. Iceberg is already in production, so people can use it. They have their own metadata service called Oxia, but that can be we can leverage etcd or Spanner as well for storing the metadata service. And I was saying, so they have this concept of lakehouse native storage. So the first writes goes to their wall object, which is again, if we are on bookkeeper, it will be on a clusters disk. If it is not on bookkeeper, then it will be on object on the object storage itself. So this compacted object is the Parquet file. This is a wall object which is an append only log file. So this log file gets offloaded as an Parquet file. So if our querying is happening from the table API, which is Lakehouse, so it will only talk to these two compacted tables. But in case we are looking at Kafka API, so it will check it will check the stream offset in both object storage as well as the compacted table and then return the response. And as I was mentioning, there are two modes. One is for latency workloads. We can use Ursa's object store. Sorry, where the latency is relaxed, we can use the object storage. Or for latency sensitive applications, we can use latency optimized wall, which gives faster acknowledgement based on bookkeeper. Again, because they have made the brokers stateless and leaderless, we can scale up and down these brokers as and when we want, and storage remains on the object storage. So that can also scale automatically, and it makes the solution truly cloud native, where we have storage and compute separation, making them scale independently for a larger scale. We also have another project called Apache Iggy, which is an persistent message streaming platform written in Rust, capable of processing millions of messages per second with ultra low latency. But as of now, this is still in incubating status, and so this is something which we can look up, but as of now, it is not production ready. There are some other notable mentions, as I mentioned. There is Confluent Fake Cluster. There is a company called TechType, which also offers Kafka compatible solutions. Then we have S2, which is S2.dev website, which provides end-to-end platform itself, and it gives an option of ingesting at a higher rate and transforming the data on the fly as well. So yeah, those are the things. Those are the options. And then some challenges with Kafka with object storage. One will be that always you will have latency, and maintaining cache for reads and writes at broker level does put some limitation on the stateless nature of the broker. Cross AG cost will be there. Metadata overhead on Kafka on S3 does need more data. Metadata overhead means the Kafka on S3 needs more metadata, so that also has to be handled. So these are certain challenges which are there on Kafka with object storage. But yes, there are innovations happening, and companies are converging towards making a alternative for Kafka, and also the Kafka open source community is looking towards making Kafka more cost effective. And in future, we might see leaderless and stateless brokers in Kafka open source as well. And if that happens, then again, Kafka will be back in the game. Till that time, these companies are good options if we have relaxed latency requirements, and these are good options to choose from. Hope this was helpful. And if you are trying to build a later platform, you have to take a call on these things, like which type of platform you should be using. I hope this video helps you in choosing the right or making the right call. Thanks. Have a good day.